if the physical universe, the classical physical universe, first of all, really is continuous and there are really infinite precision real numbers in the physical universe, then analog computers would be able to calculate things, in principle, that a Turing machine, which is discrete, could never do. So in that case, one would have to change the definition of a Turing machine to something richer. Some people have looked at calculations with real numbers, for example, some mathematicians. Now, regarding quantum mechanics can actually do something that cannot be done in the classical world. You can have a perfect randomness from a quantum mechanical system. And you can get a sequence of 0 and 1 bits, spin up, spin down, probability half independent, and it will have infinite algorithmic information content. It won't be particularly useful information, perhaps, but it might be useful for quantum cryptography, for example. If you want to use a one-time pad, one-time pads are not very practical because you have to distribute the key to people, and if it's very big, that is cumbersome and it can be intercepted perhaps. But one-time pads, when the key of the cryptographic key is as long as the message, in principle is absolutely secure, And with the quantum process, you can get a perfect coin toss in the physical world. So that is something you cannot do with a Turing machine. You can get pseudo-randomness. You can have an algorithm that generates numbers that look random enough for most purposes, but in fact, it's going to come from a seed in a small algorithm, so it'll be very compressible algorithmically.
So quantum computers will be real randomness versus fake randomness.
Versus pseudo-randomness.
Pseudo-randomness.
Right. In that sense, yeah, that's true. So, yeah, I think these are deep questions, and in a way we're facing infinities here of different kinds.
Exactly, because my view, my naive view of infinity is sometimes being naive is not so bad. Is that you can't define the precise, and I take the word precise very seriously, the precise frontier, precise border of any part of the world. So every time you try to find the borders, you can see that it's not really a totally defined border, it's just a different intensity, and the intensity itself is the glue between the different parts that are more intense. So everything is kind of rhythm. It's like when a music, you think it's a sound is like like do, re, mi, but you don't know when the do really finishes, and you don't know when the re actually started. But you hear the music, and like if the world is something like that, so it looks determined if you play the music, but in fact the music is never the same, and it can't be the same because it's just the liaison, the relation itself that you actually can't define. But if you see something like there is do, or there is re, or there is that, like if there was particles, it's just the limitation of our experience that you can't find in reality. So
yeah, you're saying the musical score does not capture all the music. Each performance is going to be different, and it's not all in the score.
That's what I say. But not only that. Not only that. What I'm saying is, if you think that there are different, that would be like discrete differences between the different notes, even when you're listening to the music, it is just because you are unable to perceive the tiny, and ever more tiny bit. And at the end, even the concept of bit is something that you have constructed in order to go tinier and tinier. But at the end, it's just the liaison of this ensemble that counts.
Let me see if I get what you're saying. I'll put it in my own words. I think you're saying that one cannot flatten the richness of the physical world into a theory that only has zeros and ones.
Exactly.
And that may be true. There's this remark of Picasso's that I changed a little, which is, he said, art is a lie that helps us to see the truth. And I like to say theories are lies that help us to see the truth.
But that doesn't mean that it's not useful, because when you flatten the world, it helps you to make up your mind, to decide, to see something clearly. Because if you couldn't flatten the world, as you put it, you will not be able to enter into some kind of a set of actions, because you'll always have other reason to not do something or to do something else. But at one moment, you can focus, because you flatten is also a way to focus.
Yeah, you can't think without simplifying.
Exactly. It's like if on one side you have the truth, but it is totally unuseful when you get closer to it, like the mystical experience.
It's infinitely complicated.
Exactly. So the closer you get to it, the less it becomes useful, because you can't focus.
Right.
And on the other side, you focus. You're far from the truth, but you can be into action. I think life is a mix of both. And animals, or even computers for me, even if they are very, very efficient, they always stay in the focus part. But human beings, they had these windows to the truth that is not useful, but that could help somehow to focus in another way, in a superior way. That's make the specificity. So at the end of the day, what is important? That's the mystical experience. So that we can come to...
You attempt to become one with the universe in its full infinite complexity.
But it's not useful, but it can help you to see things that you will not have seen otherwise, that maybe can allow you to afterwards to focus, to focus to something else that you will not have seen. And so...
mathematicians certainly simplify. Von Neumann, one of my favorite mathematicians, John von Neumann, he said something like, the real world is complicated. Mathematics is easy, is simple. It's the real world that's complicated. Mathematics is a tremendous simplification. That's why reasoning applies. That's why you can prove theorems. In the real world, you can't prove anything, Everything is complicated.
Sure,
there are
exactly.
3 arguments for this, 5 arguments for that.
You need a flat surface to be able to prove something.
The world of mathematics is really a toy world. It's much simpler than reality. It as you say, it flattens or it focuses on something to be able to think.
But what is interesting also is like when you do really deep mathematics, as you do, as yourself, you start to flatten the world. But by doing that, in this abstract world, step by step, you are confronted to paradoxes, because even your imagination is part of the world. So in fact, even the mathematical imagination is part of the world. So necessarily, you are confronted to paradox. And the only way to try to go beyond this paradox is to unflatten the world abstractly, and you do that. And at the end, you have some kind of another way to perceive infinity, to formalize infinity, to formalize to be like in a world that is not so flat, but through mathematics, through the way that you have used to flatten the world.
Most people think mathematics is reductionist. The kind of mathematics I do is exactly going in the opposite direction.
Exactly, that's what I meant.
I'm trying to show that mathematics contains infinite complexity, that it's an open system, and that it's an unbounded amount of imagination. There's room for an infinite amount of creativity. I interpret Gödel's incompleteness theorem as positive, not negative. It means if Gödel's incompleteness theorem were false and you had a formalization of all of math, it would, in a sense, trivialize math. It would be a cemetery.
Exactly.
And what Gödel shows is that math will not allow itself to be captured and squeezed into this. And I view that as the first step in the direction of a mathematics of creativity. My own work tries to show that the stage is very big, and there will always be new ideas, even in the world of pure math. So I'm trying to go in the opposite direction from mathematics as a little box that you're trapped in.
But talking about directions, I think there are two directions in the way people do mathematics, seeing you and seeing other people. There is the way like mathematics is useful to feel better, to feel secure, so to flatten the world, to make things predictable, to make things like computable, to limit them, to try to make us feel that everything is working the way it has to work.
Yeah,
and there is another way.
Reason.
Exactly. And there is another way, step by step, when you get closer to thinking about infinity in mathematics, that you actually open the windows, open the box, and you unflatten. So it's like if mathematics was having those two sides.
Right, that's what I try to do, and that's what I think Gödel's incompleteness theorem, viewed positively, shows that mathematics will never be finished, will never be complete. There's always more to discover, and I think this is good news, not bad news, actually.
So we are getting closer to the question. One of the questions I wanted to ask today in our last session is, what's the point to infinity? What's really the point? I think we
to inspire us, to challenge
but
us.
we partly, yes, in a way, because we partly answered this question, saying that, in fact, for me, the point of infinity is to make ourselves being able to unfocus from what is directly and purely useful. So you will look even at what you were seeing as being objective, and because you focused on something that is useful, that works, etc., and you'll say, what's the point of that? And you can see that there is something else, and something else, and something else. By doing that, at first sight, you can see, oh, that's a waste of time on the useful point of view. But in fact, it could be useful in another way, because if you are able to see that you could focus in another way, that opens a window to be useful in a way that you would not have thought before. So I think the thinking about infinity, for instance, infinity of possibilities, helps us to understand that what were our current priorities could be something else, and could be something that could become useful, that is not useful now, but could be useful in another way. It's what makes abstraction something that is concrete in another way, that could create its own concreteness, but afterwards, because you are aware that there is not only one possibility, that as we say, that the world is not flat.